I'm designing a seismometer to be used for the Europa mission involving ice drilling and landing of a submersible. This seismometer will be used to detect subsurface ice movement, as well as potentially the dimensions of the ice. This is relevant because on October 14th, Clipper was launched, and I think this mission will seek to model that mission. Okay, so just some basic fundamentals of a seismometer or a seismograph, and the graphing component is involved. Initially, a mass is suspended by a spring on the frame, and this mass is at rest. When the ground shakes, the frame moves from the seismic activity. However, the mass will want to resist the movement due to inertia. So the resistance of the movement is modeled by this pen attached to the mass, and this will trace the relative motion of the mass on the recording surface, such as a paper, and then the amplitude of this motion is shown vertically. Okay, so just the methodology behind my design. As you can see on the top right, there's the setup. I've got an Arduino Uno R3, an MPU 6500 6-axis accelerometer and gyroscope, an alert LED, resistor, wires, breadboard, and base. Some of the software I've used has been Arduino IDE and MATLAB, specifically the Arduino hardware support package, the instrument control toolbox, and the signal processing toolbox. And in the bottom right is an electrical schematic for those interested. Okay, just some results of my prototyping. So here's my MATLAB code. To summarize, I read the sensor data within MATLAB itself. I set up a live feed. I removed noise and DC offset. Here's a parallel view. And then I applied some fast Fourier transform. So here we can see both the MATLAB code and the live testing. As you can see above, acceleration for each axis is shown. So that would be red is X, green is Y, and blue is Z. At the bottom, you can see whenever there's a vibration or a shake of the testing board or a tap, the LED will light up due to a significant change in the acceleration. And all this was performed within MATLAB. The second here, you can see this is the fast Fourier transform of each axis, and the peaks of each graph is the dominant frequencies, which are shown below in the command window right there. Okay, just some sources of error and potential next steps. So the accelerometer was not completely calibrated, and the wiring was not fully soldered. Potential next steps include further developing the seismometer for accuracy and precision, improving on the FFT, and additional components. Thank you very much.